back to here, basically what we're working through and what I want to work my way through, starting today and working my way towards the end of the week, is that what I want to try and build is this newsreader application. Okay, so there's an API here that NPR has put out, and so they're actually latest tech news stories. So it gives you back a JSON response that tells you here's the name of the feed. Up there you can see the technology, there's a description, etc. But then underneath items, there's all the latest stories, right? And this actually updates. If you check it over the course of the week, you'll see it changes daily as it posts new stories. So we're going to try and take this and turn it into a newsreader application. This works really well because it's a good example of actually a real world scenario. Like, what does it look like if we've got what complicated JavaScript returns that we actually look at on a regular basis? How do we deal with that? How do we model that? How do we work with those network requests, et cetera, et cetera, et cetera. Cool. And it's also helpful because there's images on these stories. And so it also lets us talk about how do we pull those images down, which we're going to do with Casa. Cool. So this is what we're working through. We're going to work through this the entire week because there's a lot of pieces that we have to put into place to get to where we want to be at the end. Cool. Okay. So what I've got today and what you pulled down in that example is the first few versions that we're just going to look at today. So there's 5 versions out there. We're going to actually be looking at more versions tomorrow when we're looking at retrofit. So this is just the first cut for what we want to talk about today. So if you've looked at the repository, you might notice that there's a Readme attached. So there's a Readme attached that kind of mentions what each of the different versions are. So there's a version 1, 2, 3, 4, 5. They'll give you a brief description and some of the things that are in that version. Okay, so I'm going to walk you through all of those different versions and kind of explain what's going on and why the code is the way it is. I had originally thought about maybe doing this as a code along and having you guys kind of code with me, but as I was building up, it's like, oh, there's a lot of places here to fat finger something. I think I better just give you my finished version and let's talk through it rather than dealing with all the like, hey, I accidentally missed one character here and the whole thing breaks. Because there's a lot of gotchas here. There's a lot of places to make a mistake and then you get serious problems. Cool. So that's why I want to make sure you had do it this way and you have my version. Okay, so where we're going to start here is in this initial version of the newsreader. So that's Tech News 1. So I'm going to open that up in Android Studio, which I think I already have. So the way I got there, just to backtrack a little bit, is I went to the repo, I picked Tech News 1, I hit OK, project's open here. Okay, so we already talked about, the first piece in there that I need to put in there, which is the permissions. Like, that's step 1. If you don't put the permissions in there, then it's going to tell you later on that you don't have access to the internet. Okay. So that's step 1. I was thinking the lights are still on, but they are. Okay, so the next thing I want to look at is kind of the layout per se, the layout of this application. So we're going to kind of look at what's there already. So looking at the layout, there we go. And I'm going to go to Blueprint View. Or no, I want to go to Design View. There. So what we've got is pretty simple. I've got on the outside, I've got a constraint layout, as you can see in the hierarchy. I've got a button, which is anchored and centered at the top, which is what we're going to use to initiate a request to the server. So basically you click on the button, it sends a request to the server to get that JSON feed that we just looked like, and then pulls it down and puts it into the text view that we see down here. You might notice that text view is inside of a scroll view because it's actually going to be a lot of text, right? If you already looked at it in the browser, you saw there's a whole bunch of stuff coming out. I might mention in your, as far as looking at the feed, your feed might look like this. And this is actually how it's going to look like when we pull it down, is as this raw. The reason mine's looking like this fancy parsed is because I have a plugin in Chrome that makes it look nicer. Because I do enough with trying to look at JSON responses that I want to have them look like this rather than looking like that. So that's the kind of layout there. That's the layout setup. Pretty simple, kind of stuff we've already talked about. Okay. So I'm going to go down now and we're going to start looking at the Java code that's in here. Expand this out so it's easier to see. So starting from the top, we're in main activity. I'll actually expand some of my imports. I've got main activity. You can see that there's what we call two constants declared up top. There's a constant named log tag and there's a constant named base URL. And what do I mean by constant? Constant is this private static final thing. So private meaning that this variable is only accessible from within this class. Other classes can't see it. Static meaning that there's only one copy of it, not a copy for instance. That's the difference. If you don't mark something static, then remember it's an instance variable. But if you mark it static, a lot of times people will call that a maybe class variable because it's attached to the class instead of attached to the object or the instance. Okay, so there's only one copy of this, and then I marked it final. Final means it can't be changed. Final means that once you've assigned a value to it, I can't assign a new value to it. So the combination of static final, those two keywords we use anytime we're marking something as a constant. Cool? Make sense? So you'll see that convention, and you'll notice that I put my constants the first thing in the file. That's also an important convention, is any constants you have, list them first. Okay. Another convention in here, you'll notice that rather than camel casing these variable names, that I have put them all in caps with those underscores. Snake casing, uppercase snake casing. That's also a convention in Java. If you've got a constant, you do uppercase snake case like that, and you mark it static final. Sometimes they will be marked public, sometimes they'll be marked private, depending on whether or not you're going to access that in other files. But those are the important things to pay attention to. Everybody got that? We haven't done any constants yet in this class, so that's something I wanted to call out and make sure that everybody pays attention to. That's how you're going to mark your constants, because we will have some. Next up, we have my views. So here, I'm only asking for two things from the layout. Is I need access to the button, and I need to access the text view where we're displaying the output. Cool. I don't need access to the scroll view. I don't need access to the constraint layout, so I'm not asking for those two things. I'm just asking for these pieces. That part should be pretty familiar. Same thing we've done in the last 2 weeks in terms of working with UI. So I've got a reference to those two elements. Similarly, when I go into OnCreate, you'll see that I'm calling find view by ID, and I'm getting both the fetch button and the output text. So I get both of those as the first sort of setup. So far, so good. Keep looking. I go down to here. I say register listeners. So you can see registering a click listener for that fetch button. When you click on the button, it calls fetch feed. Cool. Everybody good with that so far? That part should be, hey, we kind of went over that over the past week or two, so that shouldn't be anything too new. So where is all the interesting code? Well, over in here in fetch feed. And if you've kind of taken a look at it, you might see that there's a good amount of code in this function. Okay, there's a good amount of code in the function that we have. Starts at line 43, goes down to line 84. So there's about 40 lines of code already in this function that we need to talk about. Now, Before I get too deep in there, you might have already tried this program. Let me go ahead and try it just so we're on the same page here. Go ahead and run it on the emulator. Give it a second to start up. I'm going to hit fetch, and it will say that there's an error. Say error fetching news failed for some reason, see the logs. I'll look at why this is, right? So this should be failing. This is expected from the code example that's here. Okay. In version 2 of this, we'll fix that error, but I want to call your attention to this version first to kind of show you why we need to make the transition to the second version. Cool? Okay. So if you tried it, it's failing, that's okay, that's expected. And we'll look at why that is. But first I want to show you what we have. Okay, so first thing I do, and there's a few patterns in here that we're kind of going to follow. So the first thing you'll notice is when I get in here, I immediately log something. I immediately say log I, fetching the newsfeed. It's a good habit to be in so that you know, oh, the thing started and it's on its way. Like, because oftentimes when we're working with these network queries, it can be hard to tell if the process is even started. If you don't have something in a log, it may be hard for you to even tell, oh, it started the process. Cool. So I have this convention that I always start a log statement first. You'll notice it's I for informational. You'll also notice that here, when I'm doing the log, I'm using that log tag constants that I've declared on the top. So rather than putting main activity everywhere, I'm going to put log tag. Cool. That helps save some code, make sure that I'm using the same tag consistently. So that's an important thing, and you'll see anywhere here I do a log, I'm going to always use that log tag. Okay. So next thing, I'm declaring a variable. HTTP URL connection is null. Okay. The scope of this variable is really important. You may notice that I've declared it outside of the try. Okay. I've declared it outside of the try because I do need it at that scope. The reason I need it at that scope is, remember how I said we need to disconnect in the finally? In order for me to disconnect in the finally, it has to be declared outside of the try. If I don't declare it outside the try, I can't run my disconnect over and finally because it would be only scoped to the try block. Cool? So that's why that's there. Okay. So I might go ahead and skip over the try. While we're talking about that, just to briefly look at what's in finally. So you'll notice in finally, I'm saying let's disconnect the connection. See that? I'm disconnecting the connection. So that's really important. In fact, I usually put those two things in first. Declare the variable, and then disconnect, and then start implementing the try. Otherwise, I forget about it. If I do that last, if I write this from top to bottom, I will forget to put that finally clause in. I tell you every time. So I always do that first. You'll also notice in here I'm doing something that wasn't in that example online, is I've got an if statement here. This connection does not equal null. That is super important. If you forget that, your application may well crash. It's very likely to crash. Okay. Why? Well, notice how I initialize the connection. The connection is initially null. Okay. Depending on where in the try it failed, it may have never created a connection. Depending on where in the try it failed, it may have never gotten to the point where there is a connection. If there's not a connection, I can't try to disconnect, or I'll get a null reference exception and crash the application. Does that make sense? So that's why I'm checking it with an if statement. I'm saying check to see if there actually is a connection, because it might still be null. It might still be null depending on where in the try it failed. Okay, and that's a general pattern. If you're disconnecting or closing anything in the finally, all of those statements should be wrapped with an if statement to check that it's null before you try to close it, because it's a very common mistake. It's a very common mistake to try and close something that's null. Okay, so that's part of the pattern. Next thing, going into try. Okay, so the next step here is, remember, I need a URL to open the connection with. Okay, so in order to create a URL, I'm going to say, let's create a new URL. I'm using that base URL constant that I've defined on top. So rather than directly putting the URL here, I've got it up to the top. Makes it easier to potentially change it down the road if I wanted to point to another URL. Cool? So just convention, you usually don't put the URL hard-coded. You're usually going to put that as a constant up top. So I say new URL, save that into a variable called URL. Remember that point, that's trying to parse the URL. Remember I said that's trying to parse the URL. That means if you look at this and you look at the definition and the code for this URL, you'll see that it throws, it's listing here as it could potentially throw a malformed URL exception, right? It'll throw a malformed URL exception if that URL isn't valid, okay? So that won't happen in our case because I know this is a valid URL, but I still have to catch that exception because it could happen, right? The runtime doesn't know if that's valid, okay? I know that it's valid, but Java doesn't know that. Cool? So things like, what would be an invalid URL? Well, the protocol has to be there. So if I said something like just feeds.npr.org, that is not a valid URL. If I tried to parse that, I would get a malformed URL exception. Everybody good with that? So that can happen, and you always want to, you have to catch for it, and you always want to plan for it, because sometimes things happen where you misconfigure that, or you have the wrong URL. I can't say how often that, actually I've seen students have problems with number one there. Okay, so because of that, you'll notice it down at the bottom, and I'm kind of skipping up and down because this code conceptually doesn't necessarily, I don't really think about it from top to bottom. So you'll notice that I've got a few catches here. Notice I'm specifically catching malformed URL exception. Okay, so if there's a problem with the URL, I catch a malformed URL exception. You notice I'm calling this show error message function, and I've got a specific error message for that case. So if it's that case, then I'll say error fetching newsfeed failed due to a bad URL, right? So the user can actually tell, and there'll be a different error based on what kind of error occurred, right? There'll be a different error message. That means that they can send that error message back to us, tell us, here's the error I had in the app, and I can say, oh, okay, well, it was this kind of exception. Because oftentimes what you're going to get back when you're supporting an end user is just a screenshot of what's on the screen and no other information, right? If you're lucky, you'll get the error message that they see on screen, right? So if I can get those two words, bad URL, back to me, then I know that's what's up and that's what I need to fix. Cool? You'll notice that there's a few catches there because there are a few things that can go wrong. So first step is to try that. Check for the malformed URL exception. The next process is how we're actually opening the connection and configuring it. Okay, so I'm going to say connection. That's equal to, hey, call URL.open connection, as we saw before. We're casting it to that HTTP URL connection because we know that the protocol is HTTP or HTTPS in particular. Cool. Okay. Next thing. Set connect timeout and set read timeout. So connect timeout is how long are you willing to wait before it times out opening the connection to the server. So this is measured in milliseconds, so 15 milliseconds. I'm saying try to connect to the server. If you don't connect within 15 seconds, go ahead and fail it and abort this whole process. Does that make sense? So we can set a timeout. That might seem pretty high, but you have to recognize when you're dealing with mobile networks, things are quite a bit slower than when you're dealing with, especially if you're dealing with a 3G network or a 2G network. Things are quite a bit slower than they are on your 4G or your Wi-Fi network. Cool? So connections may take some time. Also, the other thing to remember is your customers are international. So your speeds may vary based on the country you're in or the particular place you're in. Maybe they're in the country, maybe they're going over satellite, maybe they're over on the other side of the globe. So there's a lot of things that can change that. So we usually have that pretty big. Next thing is the read timeout. And so the connect timeout is how long do you want to wait to actually open the connection. Initially, the read timeout is how long do you want to wait between packets, okay? Between pieces of information that you're receiving from the server. Does that make sense? So they're an interim time. So we're saying also 15 seconds there. So if there's 15 seconds goes by and I don't get more data, go ahead and close and abort the connection and call it a failure. Because that means the server probably had an error, crashed, shut down something midway, and we're not going to receive the rest of that data. Cool? Does that make sense there? Those two timeouts? Those two timeouts are important kind of thing to tune, but you'll notice I've set them up decently high. I've also seen these set up all the way to a minute, depending on if you really need to deal with network connectivity problems. So these can be pretty high. Next thing up is I've got the request method. So I'm saying that this is a GET request. If I wanted a POST request or put request, etc., I would put the particular method there. I'm then saying set do input. Set do input is just saying that I do want to read the response, which is kind of a weird thing. We probably always want to read the response, I would assume. So I'm typically going to go ahead and put that in there. Say true. Yes, I do want to read the response, but I'm not calling set do output because I'm not sending any data to the server. Does that make sense? It's not a post request. I don't need to post any data. I just need to read the response. What's going on, Aaron? Okay, just checking. And then last thing we're doing is calling connect. Okay, this is the place where we actually start talking to the server. Up until that point, nothing has actually gone over the network. Yes?
At which line did it become non-null, the connection?
The connection?
Yeah.
Up on line 50. Line 50 is where the connection became non-null.
Okay.
Right. So up on line, so if the error occurred here, then the connection would be null. Or if the error occurred here, the connection would also be null, right? Okay. Once it's gotten past the connection being created, past those two lines, then we're okay, we have a connection. But it's not actually gone to the server, right? We have an object, but we don't have a connection, nothing's gone over the network, okay? So this starts the network communication. Cool? So if you know a little bit about that, that's where we do the first maybe DNS query and send the first packets over the network at this point. Okay. From there, we're going to start reading the actual data. And so you'll notice there's a set of statements here. They are kind of weird, right? And so this is where we need to talk a little bit about the syntax. Okay. So the first thing I do, and I'm going to come back to the fact that there's a try statement here, because this is kind of an interesting thing. First thing that happens in here, I say connection.get input stream. Connection.get input stream. So that gives me the stream where I can read the data from, right? So it's reading we call it an input stream because that's the type, but it's actually reading the response. So from the server standpoint, this is kind of an output stream. From our side, it's an input stream. Cool? Okay. So I get that. I save it to a variable called stream. You can see the type of that variable is input stream, which is part of the java.io package. Okay. Remember, a stream is basically a series of bytes. So I can read that series of bytes. Now, what's this try? Okay. Notice that this try statement is weird. It's different. Notice that there's no catch that goes with it. Does everybody see that? That try statement does not have a catch, doesn't have a finally. And where I've put that line of code is not inside of the try, but inside of a pair of parentheses before the try. Does that make sense? Before the try block, okay? It's a different syntax, okay? So in Java, write this down. This is the try with resource statement. Try with resource. That part in the parentheses is the resource. So try with resources is a newer bit of syntax in the Java language. Was introduced in the last few years. But it's really, really important. And what it does is it automatically cleans up resources for you. So you remember how I had to go with the connection? I had to remember to put things into the finally, and I had to remember to disconnect and check if it's null, etc., etc., etc. What this does is it basically implements the finally for you. Does everybody hear that? This essentially implements the finally block for you. So you give it this object, it now has a reference to the string, and it will automatically close it down at this closing curly brace at the end. Close it down here, as if like you had a finally clause there to say close the string. That's what it's doing. It's automatically closing it for you, regardless of what happens. So make sure if there's an error, if it goes through successfully, either way, it'll make sure that that stream gets closed. Cool? So it's all about cleaning up your resources. The benefit to this is it's a much shorter syntax than that whole try, finally, making sure I declare the variable outside as null, making sure there's an if statement, etc. Right? It's a much cleaner syntax than doing that. Okay, it works with anything that is closable. Okay, try with resources works with anything that is closable. Specifically implements, there's an interface called closable, and it just has a single method, close. So as long as it's got that close method, implements an interface, it can just automatically close it for you. Okay, unfortunately, that doesn't work with the URL connection because the method's called disconnect, and it doesn't implement the close interface. That's why I couldn't do that with the connection, is because it doesn't implement that closable interface. Cool? If it had implemented that closable interface, I could have done this with the connection as well, but I can't. So I'm creating that stream. The next thing I'm doing is I'm creating another one. So I've got try with resources, and I'm creating what's called a buffered reader. Okay. You kind of saw in the other example, there was a buffered input stream. Buffered reader is kind of a similar story. So first I take the input stream, I'm wrapping it, you see I'm creating a new input stream reader, and then I'm creating a new buffered reader. So notice the double wrapping. So we start with an input stream. Input stream is based on bytes. I'm switching this over to a reader. Okay, so streams working with bytes, readers work with text. That's the distinction. Streams work with bytes, readers work with text. So I'm saying treat that sequence of bytes that we're getting in as instead as a sequence of characters. So we'll decode all those bytes into characters. Does that make sense? And so input stream reader is a bridge from the stream to the reader world. From the stream to the reader. I'm taking it from being a stream, converting it over to be a reader. Okay. The next thing I do is I wrap it in that buffered reader. So it's already a reader. Now I want to add a buffer around it to make it more efficient. That's all that's around it. Is it adds an additional layer of buffering so that it is more performant. That's all that's around. Very good with that?
Does it work without the buffer?
It works without the buffered, but it will be slower.
Okay.
It will be less efficient. It will work without the buffer reader, but it will be less efficient. Okay. If I wasn't working with a response that was text, then I would maybe just use the input stream and buffer that. But because what I'm reading, remember I'm reading this JSON text from the server, it's actually text, right? And that's typically what we see on the internet, is we're usually reading HTML or CSS or in this case JSON, right, I need to read it as text. Okay. So that goes ahead and deals with actually a lot of complexity just putting it in the reader. For instance, it will already go and figure out what, that will help figure out what encoding you use, because that's a common thing that occurs, is like, are you sending it as UTF-8 or ASCII or UTF-16 or UTF-32? There's a lot of different encodings that are used online, but I believe this one defaults out to UTF-8. So go ahead and take there, and then once that's set up, I can finally start reading the data. Okay. So this part is kind of like if you're using input stream, if you're using this HTTP URL connection, you're always going to do these two tries. Like you always want to go from an input stream to reader, and you always want it to be buffered. Okay. One of the things that this buffered reader gives me is I can ask for it line by line. If you're just working with the input stream reader, you can just say, hey, give me text, and it will give you a series of whatever next characters are going on. But oftentimes I want the next line. So what I can do with this is I can say, okay, what I'm doing here is I'm going to loop through that reader and read line by line. Okay, so I'm creating a string builder. Remember we talked about string builders last week. So I create a string builder, which is where I'm going to save and buffer the output as we receive it. I've got another variable called line, right? So line is going to hold the current line as we're reading it. As we read these things line by line, I'm going to save it to that variable. And you'll notice I have a while loop. So effectively what I'm doing with the while loop is I say loop, keep reading lines until we reach the end of the file. Does that make sense? Read until we reach the end of the file. Okay. This is a little weird syntax, so let's talk about what's going on here. So first thing that happens, remember you read from the parentheses, the innermost parentheses to out. So the first thing that happens is actually this part, is I say line equals reader.readLine. So go ahead and tell the reader to read the next line, do all the buffering, give me the next line, save it to the line variable. Now notice that is a single equals. Single equals is assignment. Do we normally do assignment in the middle of an if statement or a loop? Not usually. Okay. This is a weird exception to that rule. And this is actually a very common exception. You'll see this both in C# code and you'll see this in Java a lot. So I say, let's save it to a variable. And then after I've done that assignment, I'm comparing it as well. I'm comparing, is the line null? Is everybody tracking with me there? So I'm both doing assignment and a comparison. Obviously, the parentheses there are important for making sure those two things happen in the right order. So read a line, check if it's null. Because what the API guarantees us is when we reach the end of the file, it will return null. It will return non-null until we get to the end of the file. When we get to the end of the file, it will return null. So that's the signal that it returns a line of null that we're at the end of the file. Cool. It's worth mentioning I had to declare this variable up here because I can't declare it on this line itself. I can't declare it inside the while loop. I can assign it, but I can't declare the variable. Okay. So we loop, we keep looping until we've read it. In here, every time we get a new line, we're appending it to the string builder, and you can also see that I'm adding a new line. The reason I need to do that is because when I call readLine, it strips out, as I'm doing readLine, it actually strips out the line terminators. So whether they're /r or /n or /r/n, because it depends on which operating system you're working with, what line terminator you get. It's stripping those out. I need to add back my own. So I'm adding back own specifically /n because Android works entirely with the Android convention, the Linux convention, which is your end of your file, end your lines, and then /n, not the Windows convention. Cool. So all I'm doing is just reassembling those lines that we got back into a single string. And then finally, I'm going to show that text. I'm going to say, let's say output text.setText and show the text from that string builder. Does that make sense from everybody? So loop through it line by line, show the text. Make sense? Questions? Questions on that loop? It's a really good snippet of code to remember because it works in a lot of different languages. It's a really nice strip because it works in a lot of cases. And this comes up a lot when we're working with files. It comes up when we're working with HTTP requests or network requests. It comes up when you're working with all sorts of things. Even Bluetooth, I think I've done related things with this. So that's all that. Now, you might notice that there's another case in here, IO exception. So IO exceptions are sent in a lot of different scenarios. IO exceptions just is say something went wrong with reading or writing to a file, basically is the way to think about it. Or in this case, something went wrong with reading the response. Okay, so basically everything in this block, almost everything in that block can throw an IO exception. Most of the things in that block can throw an IO exception. Get input stream can throw an IO exception. Constructing these may throw an IO exception. Doing read line can throw an IO exception. Yeah, and that's it. So most of these IO exceptions will be coming from more than likely read line. And that more than likely the case we're going to get an IO exception is if something went wrong in the middle, where either it timed out or the server crashed or something of that sort. So something usually went wrong on the server side or with the network. Maybe you lost connection, maybe you went into a tunnel, that would get you into an IO exception world. Does that make sense? So if anything goes wrong with reading the whole response, we'll get an IO exception. And that's where I'm just saying, hey, there was an IO error of some sort. I don't know what kind of IO error. There are all kinds of IO errors. In fact, one of the things I will tell you about IO errors is if you test for long enough in the world of Java or Android, you will find out that there are many kinds of things that can cause an IO error. There are many things that you can't anticipate. So a lot of times we do try to avoid exceptions happening in the first place. IO exceptions, on the other hand, they're unanticipated. IO exceptions will always occur sometimes. You can't prevent all IO exceptions. So treat them as that. Treat them as they will happen occasionally. Anytime you're dealing with network requests, you will sometimes get an IO exception. There's no way around it. Everybody cool with that? Okay. Last thing in here, you'll notice I'm also having a catch for general exception to just say, hey, maybe there are other things that I didn't account for. If those other things that failed it, I'm going to go ahead and say failed for some other reason. Because it also turns out with code like this, when you're working with the network, I've always found that there are errors that I didn't prepare for. No matter how hard I try, I've always found that there are errors that I couldn't prepare for, just like I couldn't prepare for IO exceptions. So I find it always very good to plan for those. Does that make sense? Everybody following along with that? But you'll notice I've got the 3 different catches because I want different error messages to be able to debug and figure out what went wrong afterward. Cool? So that's common sort of conventions that you'll see when you're working with this. If you've ever worked with file I/O, maybe in the C# world, should look very similar to file I/O in the C# world with some changes. Or if you've done file I/O at all in any programming, that should look almost the same. Cool? Okay. So there's nothing wrong with, let me just be clear. There's nothing wrong with that function as is. But let's find out why is it crashing. Why are we not getting a response? So this is one of the reasons that logging is really helpful. You'll notice I'm doing 2 things here. In all of these catches, I'm calling the show error message. I'm logging the error as well as I'm outputting the message to the output. So I'm going to go ahead and run this program. and try that again. And I'm going to look at what's happening in log count. So no, nothing yet. Let me filter down to just info and clear out what's there so far. So I haven't initiated a request yet, but as soon as I hit fetch, boop, there's two things that should be logged. So the first thing is going to be that I actually initiated the request. And so let me filter down to NPR Tech News and there. So first thing I wrote out was that informational message at the top. It says fetching newsfeed. That was the top line here. So we can see that it did actually start the process. And then I can see that there's a big long error down here. And it fell into this third catch, right? It fell into the third catch because it's a different type of exception than the ones I was expecting. Okay. So notice what exception it is. It is the Android.os.network on main thread exception. So everybody see that?
You pointed that in?
Android.os network on main thread exception. So everybody see that? Okay. This will probably be not the last time that you see this. I always have students getting this error and asking me, why am I getting this? Okay. So make a note of why are you getting this, because you are going to likely run into it again. It's very easy to do. Because it looks like all the code is fine, but it's not. Okay. So it used to be that this error, if you're working on older Android devices, this error wasn't guaranteed to happen, but it's guaranteed on all newer devices. If I try to access the network in any way or shape or form, if I try to open a connection to a server, you're going to get this exception immediately. Okay, and you might notice down here, it happened when I called connect. It happened when I called connect. When I said take that connection and connect to it, which I believe was up here, line 55. As soon as I called line 55, it threw an exception. Because this code is running on what we call the main thread. So by hearing that, it's throwing an exception because I'm running this on the main thread. So all network calls that we make have to not be on the main thread. They have to be on another thread. And we generally call that a background thread. Okay, so everybody with me here? So this code will never work because it's always going to throw that exception. Okay. So everybody with me there? So if you see network on main thread, that means you need to run your stuff on a background thread. So there are some questions that you should have on your head immediately hearing that phrase. I guess this exception, and it says I need to be running on a background thread. Are there any new terms in there? Any terms you maybe haven't heard about in previous semesters?
Okay.
Thread. What in the world is a thread? Right? What in the world is a thread? Threads are really important. Every program you write has threads. Every program you ever write will have threads in some way, shape, or form. Okay. When we wrote all of our node code in third semester, you're writing in this Node JavaScript environment. There's one thing I told you up front about JavaScript and Node. It's single-threaded. Node is entirely single-threaded, at least by default. You only have one thread. All of that code runs in that one thread. So you have to kind of share, right? You have to say, okay, when I need to get something from the internet, I'm going to go to sleep. I'm going to wait or whatever. And another task, another job can do its work, right? So we go away, let something else do that. Okay. It is possible in Node to create background threads. And there is reason to do that. If you have long-running jobs, you're going to do that in Node as well. But we didn't get into that. So the same kind of problem, just it's worth mentioning, can happen in Node. It's just not something we did there. Okay, and it's not as specific because we're better off dealing with that one thread. But we can't do this at all. It occurs every time when you try to do this in Android. So initially, this didn't happen on Android devices. Android was like, okay, let's put things out, and then we find out, oh, people want to do things on network, and oh, it turns out that network requests often take time. So over time, what Google found is that apps that are doing network requests on the main thread don't behave well. So they put a hard block in here that says you can't do this because they want the apps to on their platform to behave better. Okay, so what is the main thread doing? Well, or what is a thread? So a thread is kind of this idea of code that's running, right? I'm doing steps A, B, C, or D, right? If I tell do this, do that, do this, do that, do that, all of that is running within a thread. Okay. And at any given point, that thread can be at whatever line number. So what's different? Actually, I should probably do this on. So a thread, we also commonly refer to it as a thread of execution, is I can tell it to do a certain steps, and I can tell it to do certain steps. So let's say this is the main thread, and this is what we call a background thread. If I have two threads, this thread can be doing work while that thread's also doing work. It allows me to run code in parallel or at the same time. That's what this is about, is by introducing more than one thread, I can run multiple bits of code simultaneously. So that means this one can be working on the UI and handling things like the main thread can be handling like click events and the keyboard. It can be rendering. It can be dealing with animations. It can be playing video. Could be playing audio, etc. Okay. But the main thread has to do like all this stuff. It's very busy. The UI thread is very busy. And so if you hog it, if you block it, if you prevent it from doing all those jobs, it's going to stop doing all those things and just do your thing. Does that make sense? So if I'm running something very heavily on the main thread, all this other stuff doesn't happen. It has to wait until that code ends. So let's say your request to go get this feed, let's say it takes a minute. During that minute, you can't play any audio, your video's stopped, your animations aren't working, it can't render any screen updates, it can't listen to or react to the keyboard, they can't click on any buttons. Not very good. Do you see that? Because the main thread is doing all these things. Okay. So what I want to do, because it needs to keep working, I'm going to go over here and I'm going to do this network request over here and let that keep doing its work. And so in general, anything that's long running, anything that takes more than just a few milliseconds, we're going to move over here. In fact, if it takes basically more than like 2 milliseconds, you should move it onto a background thread. Your deadline, your window here is, remember that this main thread is trying to render the screen, right? The target where you want to be at In order for the main thread to look good, this needs to be able to run at 60 hertz. It needs to get through all of its work 60 times a second. If anything stops that, you're going to see stutter, or you're going to see it block or stall. Now, for it to refresh so 60 hertz, 60 times a second, it needs to be able to do that refresh in 16 milliseconds. 60 times a second is equivalent to one refresh, one frame time, as we might say, in 16 milliseconds. So that's our deadline. Right? We can't push the frame time longer than 60 milliseconds. And there's a lot of stuff already in there, which is where I say, 2 milliseconds is already a pretty long time. Does that make sense? So we're talking about what might seem, in fact, 16 milliseconds to the eye is just an instant. It's really fast, right? So even things that might seem pretty good, right, especially on a good computer, might be things we need to move over. Cool. Because this network request is going to look really fast. It is really fast. Not all network requests are fast, but that's your window. You have under 60 milliseconds. In reality, just a few milliseconds to move your network request. Okay? So we're going to take that, we're going to run it over here in parallel. So while this is doing things, we're also going to be doing things. Does that help explain as far as threads is concerned? We're doing things in parallel. Okay. If I go back, maybe take a screenshot, take a snip of this for the people online. And I'm going to post that to Discord. Go back and look at some of the reading here. So in terms of the reading assignment, I will mention here real quick, there's an article here listed under optional, the additional reading, exceed the enter speed limit, and if you want to know more about that whole 16 milliseconds or 60 frames per second, look here. That's specifically about that. There's no real code in there. It just talks about why that is our target. Okay, so going back up here, there's a few articles here related to threading. So I'm going to start with the first one called Processes and Threads Overview. Okay. So I've talked a little bit about some of the terminology already, but I do want to talk about briefly, call your attention to here. So if threads and processes, if these are new terms for you, pay really close attention because this article is going to give you some definitions. Long story short, there's two ideas here that always come up when we're trying to do things in parallel. A process, you can do, if you want to run things in parallel, one way to run them in parallel is to have multiple processes. This process running this code, this process running that code, this process running that code. Well, what's a process? Well, a process is a running program. A process is a running program. So where can we see the processes in Windows? Well, I can right-click on the taskbar, go to Task Manager, and all of these things you see under the Processes tab, those running programs, those are the processes that are currently running on my Windows machine. Everybody see that? So we can see, for instance, here, there's not just one Discord process. I actually have 4 Discord processes running. To me, it looks like one program, but it's actually running separately as 4 processes so that it can do work at the same time. Cool? In fact, historically, if you look at Chrome, under Chrome, notice how many processes there are. Notice that under Chrome, I have 23 processes open. Well, it turns out the way that Chrome works, every single tab in Chrome is a process. Every single tab is a process. There's reasons for that. It all has to do around stability and making sure things don't crash, as well as security reasons. But you'll see this a lot of times, is one way to do things in parallel. However, on the Android world, your default is you have one process and one thread. Okay, so by default, your whole application is going to run in one process. If you're to look at the processes on a typical Android device, you would see one for every running program, every running app, whether it's in the foreground or whether it's in the background, whether it's just running updates or maybe Facebook is looking for new articles. That's still a process that's running in the background. There are a mention or allusion to different application components. So far we have a very simple application. It's just got one activity. But there's also other kinds of components in Android called services and receivers and providers. Long story short, we won't be writing any services, receivers, or providers because of things that have happened in the Android space. We're just going to be working with activities. So by default, those all start in the same process. There are ways to split things up and have multiple processes. That is beyond the scope of what we would be doing in this class. So as far as process is concerned, your app is going to be just running in one process. One thing to understand about processes, though, they don't share memory. So the different processes that you've got on your machine can't read each other's memory. So let's say I'm using Facebook. Facebook can't read YouTube's memory or variables. YouTube can't read Facebook's variables, which is a good thing, right? We don't want that to be polluted in talking to somebody else's variables. But if you're running in the same process, everything in the same process gets the same memory space. So that means if I have things like static variables, like remember at the top, I've declared these constants. Because they're static, there's an instance per process. Every static variable, there's only one copy of it per process. If you've got, say, 3 processes, you're going to have 3 copies of that static variable. That's a common gotcha on Android. I've run into that before. It's like, oh, this is running in 2 separate processes. So this static variable that I thought there was only one instance of, there's actually 2 or 3. So that's one thing to just be cautious of, is having things run into different processes can mean that you have multiple instances of that same static variable. Okay. All right. So a process is that container. Okay. Threads, or threads of execution, run within those processes. Okay. So your system, whatever operating system it is, can have as many processes as you want, up until it runs out of memory, up until it runs out of resources. Within each of those processes, you can have an unlimited number of threads, up until you run out of resources, right? There is some point where, every thread you allocate, and I think somewhere in here it says every new thread you create is like 64 kilobytes of memory. Like, it does add up. And it's also using a share of the CPU time. So basically, what happens is with threads, because they're running in parallel, they're sharing a CPU, they're sharing a processor, that time gets divvied up. So this thread runs, pauses, this thread runs, pauses, this thread runs, and it just goes back and forth in cycles between the running threads, oftentimes, okay? Depending on, how many cores you have on the Android device. So very kind of clear so far. So you have multiple threads within your process. They're running things in parallel. The idea is you have this one main thread that's doing all the important stuff, and then we can spin off other threads to do background work. One thing to point out real quickly here, if you block the URL thread, which you really never want to do, but if you block it for 5 seconds, you'll get that ANR dialog. Do you remember seeing that when I did the sequence app, where I told it to count up to 1 million and it froze for a long time, that ANR appeared. So that window is 5 seconds. 5 seconds is really, really generous. Because what's your actual window? 16 milliseconds, right? 16 milliseconds is where you have a problem. If you're anywhere near the ANR, you need to change your code. Because that means you're doing too much, you're doing the wrong things on the main thread. So that means that program, if I wanted it to not get an ANR, I need to move some of that code back to a background thread. Same way we're going to do with the network requests. Does that make sense? That's kind of what we're getting into, right? So unfortunately, in order to get to networks, we not only have to just talk about how do we get the data and how do we do the reading, but also how do we deal with the threading, right? Because we have to do the network request over here. We have to get the UI request here. There's another gotcha that often happens is, let's say I'm doing the work here, right? And I'm getting that response. Okay? So I do that work, and then finally here, I get down here, I've got a response, and I want to show it on the UI. Okay? Who's in charge? Who's in charge of the UI? Is it the background thread or is it the main thread? It's the main. Okay. So one of the rules when we're working with Android, and this is true for a lot of technologies, this is even true for Windows Forms, is you cannot block the UI thread. Talk about that. And that any work that you're going to do with the UI has to happen on the UI thread. Period. Any work that you do with the UI, if you're talking or manipulating, reading or writing views, etc., all of this stuff has to happen on the main thread. So this here cannot actually show the output. It can't show a snack bar, it can't show a toast, it can't call set text. It can't do any of those things. So in order for this response actually to be shown, somehow it has to send the data back to the main thread, and the main thread has to show it. And actually the diagram usually looks more like, draw this line down, and it goes in here, it executes the code, and then keeps going. So we have to somehow communicate that back. We have to start the thread, give it some data, and then eventually it has to give that data back. Everybody good with that? This part of like kicking off a thread and sending it back in response, that's usually the hard part. This is the part where a lot of people get into trouble, is getting the data back and forth between threads. It's not easy. Let me be clear. Like, it is not easy, regardless of what language you're working with. Communicating between threads is hard. And it's also made additionally hard because one of the things that you'll recognize in our languages is our programming languages don't tell you what thread you're executing, in fact. It's not part of the syntax. So the part of tracking what's in the background thread and what's in the main thread is something you mentally have to picture and have to have part of your model. Both the code itself and Android Studio itself will not tell you what thread it's running. Okay. In fact, it's possible, let's say I have a function here, that function could be called from the main thread or it could be called from the background thread. I don't know, right? So we have to be cautious about how we code. Everybody clear with that? Okay. Also another gotcha, notice these things are happening at the same time. So you can't assume that things are going to work from top to bottom. There's a little bit of this happens, a little bit of that happens, a little bit of this, a little bit of that. So the order that things happen and what happens at the same time can change. In fact, we make a network request, we don't know that it's always going to take the same amount of time. It actually varies quite a bit. So it can be that I make a network request and it takes maybe 10 milliseconds. And I make another network request and it takes 210 milliseconds. Happens all the time. So those network things are usually not very stable in terms of how long they take. All right, cool. So that's part of what we're talking about here, is we need to move things to a background or a worker thread. Okay. One of the tools that we can use, and we'll come back to this, one of the tools that we can use to send data back is this activity run on UI thread. So you can give it kind of a job to run, and they'll take it from wherever thread you queued it up on, usually the background thread. You can go ahead and run that code on the UI thread. So we'll come back to that. That's one tool we can use. But before I get into that, let me talk about the most commonly historically used tool to run things in the background. It's running a little bit longer than I thought it would. So there's this class called async task. And historically, for a very, very long time, this has been the tool that we've used to run things in background workers, right? And run things off of the main thread. It's honestly, it's a really nice, handy tool. It was built to be easier than working directly with threads, right? Rather than having to directly deal with some of these complexities, Android's like, oh, we'll use this. Use the async task. Okay. Now, if you've looked at the documentation, unfortunately, you might be greeted with this message right here. Deprecating API level 30. They give their kind of spiel about it. They say async task was intended to enable proper and easy use of the UI thread, yada, yada, yada. And there's been some issues with it, right? And so there's been some issues with running this. But I do want to introduce you to it. So, reason being, it's a good place to start for talking about what we actually want to do, what the new way of what is. And more than likely, if you're working on an application that's already out there, it's going to have async task. If you're working on any application that's already been built, that you're not starting from the ground up, there's going to be async task somewhere in that code. Cool? So let's start talking about what this is. So I'm going to skip over the disclaimer. I'm going to go down to usage. So here's an example. What they're doing is making a subclass of async task. They're calling it download files task. And their goal here is to make a task where you're going to download a file from the internet and then basically save it on the device. Okay. Now, so you'll notice they're declaring a class, download files task. We're saying that it extends. Okay, so we're subclassing async task. Async task is a generic class. So you see those greater than and less than signs? Those are the generic type arguments. Let's go back up. Look at what those are. So it takes 3 type arguments, which is a lot. If you looked at most classes, like if you looked at array list only takes 1. Okay, so this is an unusual number of type arguments. 3 is a lot. Okay, let's work through them. So the first one is params, and then there's progress, and there's results. Okay, they all have a different meaning, a different usage, but their order also helps you a little bit if you remember why they're in the order. So the first one, params, is the inputs to this task. What are the things that you're using to start the task? Progress, that middle one, is what are you reporting as you're working through it? Like how far along are you in the task? That's your progress. Typically, progress is used to update progress bars or spinners or other sort of informational messages to the user to tell, hey, I'm working on it, and this is how far along I am. Like 90% done, what not done, I'm working on this file, I'm working on line number 50, line number 100, whatever it may be. You can use it a bunch of different ways. So this is the progress. What kind of data am I using to report progress? And finally, result is what do I get when I'm done with it? When I'm done with the task, what type do I expect to see? Cool. So inputs, progress, intermediate results, and final results. So what they're declaring here is we're saying we take in URLs. Tell me what URLs do you want to download. I'm going to report an integer as I'm working that's going to say how far along am I, probably some form of a percentage. And then when I get done, I'm going to give you back a log. So everybody good with that? One thing to notice in here, we haven't done too much with generics yet. In order in Java's world, your generic type arguments cannot be primitives. All of the type arguments must be reference types. So that's why they're using integer uppercase and long uppercase, because you can't use the lowercase n to the lowercase long. So these are actually objects. So let's look at what's happening. So they're overriding first the do and background method. There's a few methods that aren't part of, that are declared in the async task. Do and background is where we do the work on the background thread. Okay, so any work that you want to do on the background, you put it in this do and background function. And you'll notice that it takes URLs, right? So this type is based on what we've declared here. We declared URL, so the parameters that we get in are URLs. Okay, so everybody with me? There's a ... here. That ... is kind of like the spread operator, kind of similar idea. We actually talk about it here as like the variable arguments operator. So this says that it can take a variable number of args. It could take one URL, it could take no URLs, it could take 3 URLs, any number you want. So it's not passing potentially a single URL, but a series of URLs. Or it could even pass an array of URLs. Any of those things are options. Okay, so it's taking in an array of URLs. And then you'll notice here that it's returning a long. That long is a result type. So it takes in params and returns a result. Cool? So this is the work that's happening on the background. So first things first, they declare some variables, the count, the total size. Okay, so we go through and one by one, each of these URLs, they're saying, let's go ahead and download the file. It's going to return the number of bytes that were in that file as a long. We're adding that to the total size. So total size is keeping track of how many bytes we have downloaded. And I call publish progress. Publish progress is part of this async task class. It says, okay, I am partway done through the process. Let the UI know about it. So it basically triggers like a progress event sort of thing that will be gone over and it will be handled over here. Okay. So we publish a progress, see what we're calculating. So we say where are we at in the process? So we're at the first URL, second URL, etc. Divide that by the number of URLs we have, multiply that by 100. So that's obviously going to give us our percentage from 0 to 100, right? If I haven't processed any URLs at all, it would be 0. If I process all the URLs, it's going to be 100. Cool? Okay. How do we handle that? Well, this part, remember, is happening on the background thread. It can't access the UI. So we go over here. In here, it says on progress update. It takes an integer, and it reports that to the UI. So here we could say like progress bar, set progress, send it to whatever that number was. And it's progress 0 here because again, ... So that effectively works as an array. It's effectively an array of integers, just like this. It's an array of URLs because of that ... Everybody good? Okay. So what else are we doing? We're checking if the task has been canceled, because maybe partway through we decided, oh, I don't want to download those files anymore. Or maybe the user left the application and we said, hey, we need to cancel this process. So if we do that, then we're going to break out of the loop and stop downloading files. If I forget to cancel, then the task just keeps going. If I don't write something in here that's checking if it's canceled, then it will run indefinitely. So we escape if it's done, and then finally at the end we're returning the total size. Say, hey, this is the total number of bytes that we downloaded. Cool. So that's the work that's happening in the background. We're downloading each file one by one, sending a progress after each file, and finally returning the total size. Next up, they implement this onPostExecute, which is where the result happens. So remember, do and background's on the background thread. These two are on the UI thread. So once we finish there, the result comes in here, and we're saying show a dialog showing how many total bytes we return. Is everybody good with that? So there's three methods that they've declared in here. We've got do and background for the background work. We've got onProgressUpdate and onPostExecute, which are on the UI thread. There's another one that we commonly use called onPreExecute, which happens before the do and background. So if you need to do any work before the task starts, you can do that onPreExecute. If you need to do work after the task finishes, you do that onPostExecute. Good with that? Okay. Let's look at example 2. So I'm going to go File, Open, jump over to NPR Tech News 2. And so what I've done in the second version is to take that project that you saw in the first version and move the work of retrieving the feed to a background task, to a background thread, using this async task. So if I go to main activity, you'll see already over in the code, you'll see that there's a fetch result, a fetch task, but you notice it's kind of inside of main activity. So main activity actually has two other classes inside of them. We call them nested classes. Let me zoom back in. Okay, so it starts out kind of the same way as the other one. You'll notice here, in terms of variables, in terms of instance variables, I have a new one. I have a new instance variable called active task. Okay, active task is keeping track of the reference to the currently running task. Is everybody good with that? Keeping a reference to the currently active task. So when the user clicks the button, I'm doing something a little bit different. What I do, rather than calling that function that I had before, I actually removed that function to fetch the feed. I'm actually using a class now. I say, let's create a new task, and then let's execute that task. Create the new task, save it here, execute the task. Cool. So that's what happens when you click the button. Also in here, you might notice that I have an onDestroy. There's an onCreate, then there's an onDestroy. Both of these are referred to as lifecycle methods. So basically when your activity comes on screen, it calls onCreate. When it goes away, when the user leaves that screen, let's say they go back to another screen, the previous screen, or leave your application, close your application, that's where that's going to be destroyed. Okay, so when it gets destroyed, notice in here I'm saying, well, if there's an active task, I'm going to cancel it. Cleanup's really important, right? So I'm making sure if the user leaves my application, I don't leave that task running. Is everybody tracking with me there? I want to make sure that I clean that up. If you don't do this, you're going to have a poorly behaved app which keeps running that task even when the user's left it. And that can cause your application to crash. It can cause it to behave poorly, etc., etc. So that little piece there is actually really important. The next thing you'll see here is I've declared another class called fetchResult. Okay? You might notice that this class is declared inside of main activity. Okay? Anytime you declare a class inside of another class in Java, we call that either a nested class or an inner class. Either words are interchangeable. Inner class or nested class. Okay? FetchResult has two instance variables. It's got an output variable and it's got an exception variable. Because remember, this operation can succeed or it can fail. So if it's successful, I'm going to just have the output. If it is failed, I'm actually going to end up putting here both an output and an exception. I'm going to have the text that we're going to show as well as an exception that I will go on. Okay. There's a constructor for it. So public fetch result takes 2 arguments. So this is our constructor. The reason I know it's a constructor is because it has the same name as the class itself. Okay, because it's called fetch result and it's in the class fetch result, I know that it's a constructor. Also notice that there is no return type, right? So normally you might have like public void fetch result. There's no type there because it's a constructor. So it takes the string output and the string exception. Okay, those are the 2 things that I need to initialize those variables. Okay. I've got a little bit of a gotcha in that notice that the variable, the parameter to that function, output and exception, is the exact same name as the instance variables. See that? They're both named output and exception. So what we get there is, remember, we call shadowing. We've got shadowing anytime you have a local variable and an instance variable with the same name. Okay? So if you have shadowing, those 2 variables have the same name, the one that gets precedence is the closer one, the local variable, right? So if I say output, I'm referring to the local variable. But what I actually need to do is save that local variable output to the instance variable. So I need to have a way to disambiguate and say, am I talking about an instance variable or am I talking about a local variable? Everybody with me there? So what you see here is I'm saying this.output equals output. This.output is the instance variable. Output is the local variable. Okay? It might seem weird to do this. It might seem weird to have a local variable and an instance variable with the same name, and you get this shadowing. This is actually desirable. This is actually considered best practice in Java. This is considered best practice to name your instance variable and your local variable the same thing as far as the constructor is concerned. So this is actually desirable. This is what we want to do. So, but that's how we have to deal with that. We have to say this output is output, this exception is exception. Recognize what would happen if I forgot to have this. What happens in this case? What am I doing?
We're assigning itself
to itself, right? I'm assigning the local variable to the local variable, right? So if I don't put the this there, it doesn't work. If you forget this, which is a common mistake, I've seen all the time I have students doing this, then you find out, oh, I constructed an object, but everything in it is null. Nothing's been set because none of the variables have been overridden. You'll also notice in here, I kind of skimmed over it. You notice I have this keyword final. I already talked a little bit. I mentioned this word final. Do you remember what the word final says? Can't be changed, which is close, but it's more specific than that. It cannot be reassigned, which is different than changed. Because there's actually 2 words we oftentimes use when we're talking about changes. Sometimes we talk about assignments and sometimes we talk about mutations. And those are both changes. This final keyword only prevents reassignments but not mutations. That's why I say the wording is important. It only prevents reassignments. So I can't assign this a new value, which is okay, right? Once I've got a result, I don't want to change that result. Does that make sense? I don't want anything to change this after the object's been created. So the only time where you can set those variables is when you're creating the object. Cool? So that's a good convention to have there, is to mark both of those final. You might notice there too, one of the benefits of marking those final is that when I accidentally did this, notice that there's a red underline on there because it tells me that those have not been assigned a value. So if you mark something final, you do have to give it a value in the constructor, otherwise you get a compile time error. If you don't mark these final, you don't get a compile time error. It just says, oh, okay, I guess you just didn't mean to assign a value to it. That's fine. So that's one of the reasons that I do that. is to help me get those compile time errors, and also avoids me accidentally later changing that variable. Cool? Okay. So this is just a container for the result that I need. The reason I need that container is because I have more than one piece of data, right? I have an exception and a string. I can't just return both of those by themselves. I can't return just a string, just an exception. I need both of those in a package. So here's my fetch task class. I'm saying it extends async task. And notice again that there's 3 types. Remember, what's the first type? First type is for async task. What are those 3?
I remember the secretary of that person.
Yeah. What's the first one? Go back and look at the documentation for async task if you don't remember it.
Params.
It's params, which are the inputs, right? So params are void, which I'm saying I don't actually want any inputs for this, right? I don't want any inputs, so that's void. What's the next one? What's the second one? So first one's params, second one's progress.
And it's an integer. Or you can set it to whatever you want, right? I
can set it to whatever I want. Okay. So notice what type it is here. It's void. So I'm saying I'm having no inputs and no progress. Okay. That's fine. Notice it's uppercase V for void, not lowercase v for void. That's because I'm using the class void, not the keyword void. Okay? So there's actually a class named void. And then I'm going to return, like my result is this fetch result object. Does that make sense? So no inputs, no progress, but it returns or produces a fetch result. You can see that I've implemented a few of these methods. So OnCreate, this, remember, happens before the background work happens. So before the background work happens, I say, let's disable the fetch button. The reason I'm disabling it is I don't want 2 fetches to be happening at the same time. If I didn't disable it, then the user could go boop, boop, and start 2 fetches at once, and that could cause some issues. Cool? Okay. So to make sure the 2 tasks don't get started, I'm disabling the button. It's a common thing to need. So disable the button at the beginning. Then we look at what the background work is. The background work takes void ... parameters because I said that it was void up in the top. It returns a fetch result because I said it returns a fetch result up top. So in here, this is where we see the code that we had previously. So I log, I try, I go through this process of setting up the connection, setting up the buffers and the readers and the input streams. And finally at the end, notice I'm saying return a new fetch result. And that new fetch result contains the string builder, so whatever we got from the server, and then no exception. Cool? So if everything goes cleanly and we get a response, it's going to return, and we're going to finish the background work here. If anything goes wrong, we get into a catch, and rather than directly, both of these cases, notice I'm not directly accessing the UI. I'm just returning an object. So I return the fetch result with the error message and the exception.
Oh, so they're both strings in each case, in each outcome, but the addition of the exception object at the end determines whether the string should be read as good or bad.
Exactly. So if there's no exception, if the exception is null, then I know it was successful. If there's an exception, then I know it was an error. Cool? Okay. So that's the changes here. So I moved all of this function, all that code into doing background, and I'm returning instead of updating the UI directly. So once the background work finishes, that returned result goes over to onPostExecute. onPostExecute takes a fetch result. I re-enable the button, Just remember, I disabled the button in on pre-execute. So I disable it here, I enable it again so they can hit the button again. And here I'm setting output text. And if there's an exception, I say if the result.exception is not null, if there's one there, we log it, and we also show a snack bar. So this is all the work that happens after the process is done. The gotcha is doing background runs in the background. This runs on the main thread. So it gives us an easy way to do that transition. We just return from doing background, and then we can display the result here in on post execute. Does that make sense to everybody? Questions? Let's try. So on a good day, we should be able to run this program. I should be able to click fetch. You saw it was disabled for a brief period of time and then re-enabled, and there's the response, right? So there's all the text that the server sent back. Okay?
Cool.
Right? So the big thing there is notice that I couldn't just directly have that code in a function. I had to move all that code into an async task. That's the important transition there. Does that make sense to everybody? Okay, now, just to see what happens when it fails, let me go up to the menu, and I'm going to switch over to airplane mode. So now that we're in airplane mode, I'm going to hit fetch, and it's going to fail because there's no network. And so you'll see that it shows the error message here, as well as it pops it up in the snack bar. And if I looked at the log, I would also see the error over here for what went wrong. So we filter down to the fetch. And where's my error? Here's my error. See logs. So I see this, but for some reason I'm not seeing the actual stack trace. I'm not sure why that is. Because I believe when I tried this, it did have an error coming out. That is odd and interesting. Checking real quick. Yep, no. I don't know why it didn't show me a stack trace of the error, but that's the gist of it, right? So you can kind of see either way it's going to show it as in the output. Yep.
What did you do to
Get
also run in the background I saw you in the classes, but I'm missing something.
Okay. So notice what I do, right? You click the button. Let's start with clicking the button. Create a task and then execute it. Okay. Execute says start that task. Async task deals with the next part of that. So it guarantees that certain functions will be called on the background or the main thread, right? So on pre-execute and on post-execute, those two functions are guaranteed to be on the main thread. Do in background, guaranteed to be on the background thread. So I don't call do in background directly, and you shouldn't.
Wait, you never called it once?
You never call do in background directly. You never call any of these three functions directly. They only get called indirectly. And notice they're all overrides. They're overriding a method in async task. So we don't call those directly. The platform calls those. So the platform is dealing with creating the background. Does that help?
Yeah, a little bit.
So there is a background thread here, we just don't see it, right? It's the thing to remember that whatever you declare and do in background is guaranteed to be run in the background.
Does it have to be titled? Do they have to be given those exact method names?
Yes, yes, those exact method names are important.
So whenever you run line 46, you create a new fetch task object,
Mm-hmm.
and then so that defines all the three methods. The two that are going to run in the main thread and the one that's guaranteed to be in the background thread.
Yeah.
And then line 47.execute is what just kind of does it on its
Yeah,
own?
just says start the process.
Oh, okay.
And by executing it, will run on pre-execute, do the background, and then call on post-execute.
I see.
It will do that process.
So you overrode.
Yes. Overrode.
You overrode
The code that's in those three methods.
and those three methods, and then that fetch task, which is extending this async task, also has an execute method. You never overrode that, right?
Correct. Don't override the execute methods. Don't override the execute methods.
Just trying to figure out where this is coming from.
Yeah. So those three are built in. We're overriding them. They have to have exactly those names and exactly those signatures. So it is pretty strict on that front. I know for sure that we're not going to get through all of this today. So the question is where do we do our breaking starting? This is probably the easiest place to stop, though, if we're going to stop, is because the other three I kind of want to do tomorrow. So again, more questions. Obviously, there's a bunch of new concepts here, right? We're seeing streams. We're seeing streamers. The execute method. I don't know if I can. If I go into execute, I can hold control and click on that. You'll notice it gets in here, it's just a stub of the code. I think I can hit download. Oh, because API 32 isn't available. So what I've got to do, actually, in order to show you that code, is I've got to change my target to 31. Target SDK and compile SDK to 31 because there's no code available for 32 yet. So back to 31, I'm targeting 31 and then go into here and there's the code for what it looks like on API 31. Not very interesting. So I call execute. You can see that it's part of this async task. It takes params ... It calls execute on executor, and you can keep kind of diving deeper.
Okay.
So like execute on executor passes some sort of executor thing plus the parameters, and yeah. I don't want to necessarily dive into all of what's happening there, but you can basically see that on pre-execute is called, there's some sort of executor thing happening. Yeah. So there are some things you can see there, but it's overall pretty deep to dive into there. Okay. So I'm going to pause the code walkthrough there. We'll pick up with the second part of that. So I've got version 3, 4, and 5 a little bit tomorrow. You do have a set of homework tonight regarding the things that we've talked about today. Because we haven't talked all of that, I'll move the due date to tomorrow because we only talked about half of what we need to talk about for that. But recognize that we have kind of a homework roughly every day around the theory. I don't have a lab or hands-on assignment for you for this right now. What my thought had been is to, once we kind of lay some of the foundation, I can get you started on building this newsreader out. But we may have to play around with that because I still want to do some more code examples with this, so I may have to grab another project, either for my code examples or for your working. Cool. So no lab work for tonight. Just keep on going with the reading and start looking at the homework.